and welcome to Sums of Anarchy. In this video, we're going to find out what decimals are. No messing about, no silly jokes, we're just going to get straight to the point. We can think of decimals as the numbers in between whole numbers being the ones we usually count with, like 1, 2, 3. Decimals are used to describe the numbers in between these whole numbers. Now you may be thinking, surely we don't need any more numbers. We've already got an infinite amount of them. Literally. Well, it turns out we do. Whole numbers are great for counting some things, like the number of people in a room, because you can't have a tenth of a person. Not an alive person anyway. But some things can't be counted so neatly. Think about your height. Let's suppose you're, 2 meters tall? And if you are, you should definitely consider a career in basketball. Or ceiling painting. Now at some point you were 1 meter tall, but you didn't just go from 1 meter to 2 meters in the blink of an eye, despite what your grandmother claims. You had to grow through all of the heights between 1 meter and 2 meters. And if we wanted to measure you accurately in meters along the way, we would have needed some numbers in between. Cue the decimals. Decimals allow us to zoom into the spaces between whole numbers, and when we do that, we discover there's a whole other world of numbers down there. It's a bit like Ant-Man shrinking down to enter the quantum realm and finding a whole new microverse. We can shrink down to get into the space between two whole numbers. Now, before we go looking for them, we need to know what they look like. Let's start by looking at how our whole numbers work. So, we have 10 digits to represent all of our numbers. Probably not a coincidence. These are the digits from 0 to 9, and we call them units. When we get up to 9, we've used all of our units, so we open up a new column to the left called the tens column, and this tells us how many tens we have. For example, in the number 34, we have 3 tens and 4 units. This is the same as saying that we counted 3 lots of 10, then we counted an extra 4. Our tens column and our units column can get us all the way up to 99, but then once again, we've run out of digits, so we open up a new column to the left. This is like the mathematical equivalent of a really successful fast food chain whose sales are so big they keep opening up new branches all over town, but always to the left of the previous branch. So as the numbers get bigger and bigger, we open up new columns to the left, a hundreds column, then a thousands column, and so on, and each column represents a place value that's 10 times bigger than the previous column. 10 is 10 times bigger than 1, 100 is 10 times bigger than 10, and so on. So if we go to the left when the numbers get bigger, what way do we have to go when the numbers get smaller? It must be right. But if we just start adding numbers to the right, how will we know the place value of anything? The reason that we know that this number is 156 is because we know that the units place is the furthest to the right, making this 5 tens, or 50, and this 100. So if now we're suddenly like, yeah, let's go add more digits to the right, numbers will lose all meaning. You won't know if you're 2 meters tall, or 200 meters tall, or 2 million meters tall, unless you try and get on a ride at Alton Towers. Well, to avoid this chaos, we use a separator, a symbol to separate the numbers on the left from the numbers on the right. This symbol is usually a dot or a comma, depending on what country you're in at the time, and sometimes the dot floats up to the middle like this. It's probably when you're in space. So once we've got our separator or decimal point in place, we can have numbers either side of this point. The numbers to the left are the whole number parts, and the numbers to the right are called decimal parts. And thanks to this decimal point, we'll always have a reference for which place value a number is in. A bit like a dropped pin on Google Maps. The units place will always be the one to the left of the decimal point. So what's the value of the digits on the right of the decimal point? Well, if every time we move to the left, we get a place value that's 10 times bigger than the previous column, then each time we move to the right, we must get a place value that's 10 times smaller than the previous column. But what is 10 times smaller than 1? We need to order a pizza. This is one whole pizza. If I cut this pizza into 10 equal slices, each slice is 10 times smaller than the one whole pizza. But sadly, not everything in the world is pizza, so not everything can be measured in slices. So what's maths for 1 slice out of 10? We call it 1/10, because it takes 10 of them to make a whole. Now, if you're familiar with fractions, you might know that we can write 1/10 as 1 over 10. The bottom number, also known as the denominator, tells us how many equal parts we cut a whole, or a pizza, into. And the top number, also known as the numerator, tells us how many of those parts we have. But we can also write it as a decimal. In fact, decimals are just another way of writing fractions. This column here to the right of the decimal point is called the tenths column. So if we have 1/10, we'll put a 1 in this tenths column, and now we can read it as 0.1. If we have 2 slices out of 10, we could write that as 2 over 10 in fraction form, and this is 2/10. So in decimal form, we put a 2 in the tenths column, and we can read it 0.2. In the same way, 0.3 means 3/10. 0.4 means 4/10, and we can keep going all the way up to 0.9, which is 9/10. But then, just like with our whole numbers earlier, we run out of digits. What do we do if we get another tenth? Well, 10/10 is the same as 1 whole. And remember, the whole parts go to the left of the decimal, so we have 1 whole and no extra tenths. Unless we get another tenth of pizza, in which case we'd have 1 whole and 1/10, or 1.1. But let's just get rid of this extra slice for a minute because we've just exposed a secret of the whole numbers. Every whole number has a hidden decimal part. They've all been leading this secret double life. The whole number 1 can be written as 1.0, and there's no difference between these amounts. This 0 is telling us that there are no decimal parts, and when there are no decimal parts, we usually don't bother pointing that out. It's a bit like labelling jars in the kitchen and coming across an empty one and labelling it empty jar. We can see that. So although every whole number can be written in decimal form by sticking a 0.0 on the end, we often just leave out the decimal part if it's empty. Alright, so now we've seen what decimals look like, let's get our Ant-Man on and go and find them on the number line. Here are our whole numbers, but if we zoom in between the 0 and the 1, we'll find that the line has been divided into 10 equal parts, just like our pizza, and each part represents 1/10. The same happens between 1 and 2. The line has been divided into 10 equal parts again, and this is why you didn't just go from being 1 metre tall to being 2 metres tall. At some point you must have been 1.1 metres and 1.2 metres and all these other measurements in between. And these tenths are happening between every 2 numbers on the number line. But it doesn't stop there. Each one of these 10 parts can be divided into another 10 parts, and each of those 10 parts can be divided into another 10 parts. It's like number line inception, and we could keep going into smaller and smaller parts until even Ant-Man couldn't see them. But we'll explore that in the next video. Now, don't worry if it takes you some time to get your head around the idea of decimals. It's a pretty big thing discovering there are an infinite amount of numbers between the whole numbers. Or maybe it's more like lots of really tiny things. But either way, it's a bit of a jump between hearing about a concept for the first time and completely understanding it. But much like decimals, you can split that jump into smaller parts. And now that we've discovered the tenths, hopefully this video has helped you get a tenth of the way along to conquering them. If you didn't find this video completely pointless, let us know by hitting the like button. There's a PDF worksheet to accompany the video which summarises what we've learned and provides practice questions to test your understanding. You'll find a link to that in the description below. Let us know in the comments if you have any questions or if you want to request a future video, and be sure to subscribe for more maths tips and tricks. See you later.